Hello everyone, today we will discuss the circle equation. So, what is circle equation? Circle equation has the following form: x minus 8 squared plus y minus b squared equals r squared. This is the common form of the circle equation, where a and b are the coordinates of the center of the circle, and x, y are the coordinates of the point which lies on the circle, and r is the radius of that circle. As you can see here in the graph, A is the x-coordinate and B is the y-coordinate of the center of the circle. If we connect them, we will get the point O, and segment R is the radius itself. Actually, there is another form of circle equation: x squared plus y squared equals r squared. This form is obtained when the center of the circle lies in the origin, means in the point 0, 0. X, y are still coordinates of point which lies on the circle, and r is the radius. So as you can see, the center of the circle lies in the origin. Now let's prove the second form. So initially we had x minus a squared plus y minus b squared equals r squared. So if I substitute point 0, 0 instead of a and b respectively, I will get x minus 0 squared plus y minus 0 squared equals r squared. And this eventually gives me the second form of the circle equation: x squared plus y squared equals r squared. Since x minus 0 is just x, and to the power of 2 will give me x squared, same as here. So, what you should remember when you're solving the circle equation problems. First thing are the formulas of completing the square. So x squared plus bx and x squared minus bx. So this one is equal to x plus b over 2 squared minus b over 2 squared. And this one is very similar to the first one, but here we have minus in the first bracket. So these two are the formulas of completing the square. For example, you have x squared plus 4x plus y squared minus 6y, and in order to convert it into the form of circle equation, you will have to use these formulas. So we will have x plus 4 over 2 squared minus 4 over 2 squared plus y minus 3 squared, 6 over 2, which is 3. We'll write it this way for now, minus 6 over 2 squared. So we will have x plus 2 squared minus 4 plus y minus 3 squared minus 9. And often it's equal to 0. Then if it's equal to 0 here, we will have x plus 2 squared plus y minus 3 squared equals 13. So this one is the converted form of the original equation into this one. So the second thing you need to remember is the formulas for finding the length of the segment. For example, I have point A with coordinates x1, y1, and point B with coordinates x2, y2. So distance of AB will be found using formula x1 minus x2 squared plus y1 minus y2 squared. For example, I have origin 0, 0, and for example point B with coordinates 3 and 4. So in order to find the distance OB, I will use the formula and substitute 0 minus 3 squared plus 0 minus 4 squared. It will give me 9 plus 16, which is root of 25, and the final answer is 5. And the third thing you need to use is your logic. You need to read the test properly and understand the question properly, of course. So let's solve some circle equation problems. For example, find the equation of the circle which has center at the origin and passes through the point 3, 4. So if our circle is centered at the origin, means I will use the second form of circle equation: x squared plus y squared equals r squared. and the point which it passes through is 3 and 4, which means I can substitute x and y values, y coordinates and x coordinates, into this equation. So I will have 3 squared plus 4 squared equals r squared. From this point, I get that r squared is equal to 25. My final answer will be x squared plus y squared equals 25. This is the circle equation which passes through the origin, which is centered at the origin and passes through the point 3 and 4. But this one was easy. Let's look through the other ones. So, for example, find the least distance between point A with coordinates 5, 5 and the circumference of this circle. So, let's write it down. X squared minus 2x plus y squared minus 4y plus 1 equals 0. And we have point A with coordinates 5 and 5. So let's convert this circle into proper form. So we will use the formulas for completing the square. So we will have x minus 2 over 2 squared minus 2 over 2 squared plus y minus 4 over 2 squared minus 4 over 2 squared plus 1, which we had initially, and it's all equal to 0. So x minus 1 squared minus 1 plus y minus 2 squared minus 4 plus 1 equals 0. From this point, minus 1 and plus 1 can cancel out, and I will move minus 4 here. So we will have x minus 1 squared plus y minus 2 squared equals 4. Now we converted it into a normal form, proper form. Now we can easily find the center of the circle, which is 1 and 2, and radius is just 2. If we try to draw this circle, we can really draw it not to scale, just to show that 1 and 2 are connected to show the center of the circle. For example, we have something like this, and point 5 and 5. Why do we need this? So you may have two tasks. The first one is to find the distance between a point and the center of the circle. You will just use the formulas for finding the distance between 2 points. And the second one, like in this task, you will need to find the distance between a point and the circumference. What does it mean? It means that you will find the distance between this point and here. The circumference of the circle starts here, which means you will again find the distance from point A to the origin, to the center of the circle, and subtract this segment, which is radius. So now we will find the distance between point A with coordinates 5, 5 and point O with coordinates 1 and 2, using the formula of the length of the segment. 5 minus 1 squared plus 5 minus 2 squared, which will give us again root of 25 and 5. Since we need to find the distance between the point and the circumference, I will need to subtract radius from the total distance. The final answer is 3. That is a bit harder. You should be more careful with this one. So let's move on to the next one. The third one is find coordinates of the circle center. X minus 4 squared plus y plus 2 squared equals 25. From this point, you can easily find the center of the circle because it's the common form of circle equation. X minus a squared plus y minus b squared equals r squared. So the center will be 4 and minus 2 respectively. You can even find the radius because r squared is 25, then r will be just 5. So that's it. That's easy. Next example, find y-intercept of the circle. X minus 4 squared plus y squared is 25. So whenever we look to find the y-intercept, we'll keep in mind that x must be equal to 0. So I will substitute 0 instead of x here. I will get 0 minus 4 squared plus y squared equals 25. From this point, I get that 16 plus y squared equals 25, and y squared equal to 9. And y equals to plus minus 3. It means the first point is 0, 3, x and y, and the second point is 0 and minus 3. That is my answer. It's not that hard. So let's continue. The next one is find x-intercept of the circle. So x squared plus y squared minus 4x plus 2y minus 5 equals 0. We need to keep in mind that this circle is given in not proper form, is improper form. So we will group x's and y's and use the formulas of completing the square. So x minus 4 over 2 squared minus 4 over 2 squared plus y plus 2 over 2 squared minus 2 over 2 squared minus 5, which we initially had, and it's all equal to 0. Now let's simplify it. X minus 2 squared minus 4 plus y plus 1 squared minus 1 minus 5, which we initially had, equals 0. Now let's move all the numbers here. So now we will have x minus 2 squared plus y plus 1 squared equals 10. Now, if we're looking for x-intercept, y must be equal to 0. Many students do like this, find this, and then substituting 0 instead of y. But you can do better. You can just substitute it from the very beginning. I showed it because many students do that way, wasting their time. So you can just, if you're looking for x-intercept, you can just substitute y 0 and get x squared minus 4x minus 5 equals 0 and solve the quadratic equation. You can solve it using discriminant, Vieta theorem, or private cases. So the first root and second root will be minus 1 and 5 respectively. Now it means that the first point is minus 1, 0, and the second one is 5, 0. That's it. So let's continue. Find the equation of the circle which passes through the point M and has the same center as the circle. So let's write it down. We have a circle x squared plus y squared minus 4x minus 6y minus 10 equals 0, and point M minus 3 and 5. So the question is to find the circle equation, which has center as this. So let's find the center of this circle, grouping x and y's. Using the formulas completing the square, we'll convert it into a proper form. So we will have x minus 2 squared minus 4 plus y minus 3 squared minus 9 minus 10, which we initially had, equals 0. X minus 2 squared plus y minus 3 squared equals 23. Now, the center of this circle is 2 and 3. We need to write down another circle equation which has the same center. So we will have x minus 2 squared plus y minus 3 squared again, but now it is equal to r squared. So the center is the same, but the radius will be different. So in order to find radius, as we did before, we need to substitute this point into our equation. So minus 3 minus 2 squared plus 5 minus 3 squared equals 25 plus 4, which is 29. So the final answer will be x minus 2 squared plus y minus 3 squared equals 29. Centered the same as this circle, but has a different radius. And that is your answer. It's a bit tough. You need to be more careful with these ones also. So let's continue. Number 7. Find intersection points of the circle x minus 3 squared plus y plus 2 squared equals 2 and 2x minus y equals 5. So we have x minus 3 squared plus y plus 2 squared equals 2 and line to x minus y equals 5. Let me just check it. Yeah, everything's okay. So if these two are intersecting, it means at the point of intersection they are equal. So I can find y from here to x minus 5 by moving these and substitute the value of y here. I will have x minus 3 squared as we had before plus, and I will substitute 2x minus 5 instead of y here, 2x minus 5 and plus 2, which we initially had, squared equals 2. Now let's simplify it. We will get x minus 3 squared plus 2x minus 3 squared equals 2. Let's open the brackets. X squared minus 6x plus 9 plus 4x squared minus 12x plus 9 equals 2. We open these brackets using the formulas of brief product. A minus b squared equals a squared minus 2ab plus b squared. So the next thing we need to do is to simplify our expression. 4x squared plus x squared will give me 5x squared. Minus 6x minus 12x will give me minus 18x. 9 plus 9 will give me 18 equals 2. And from this point, I can move to here, changing its sign, and we will get 5x squared minus 18x plus 16 equals 0. Again, quadratic equation, which we have to solve. Let's solve it using the discriminant. B squared minus 4ac, which is 324, minus 4 times 5 times 16. So the discriminant will be just 4. x1 and 2 is found using the formulas minus b plus minus root of discriminant divided by 2a. So the first one will be 18 plus 2 divided by 2 times 5. So it will be 20 divided by 10, which is 2. And the second one will be 18 minus 2 divided by 10, which is 1.6. Now you have two x's. And since we wrote in the very beginning that y is equal to 2x minus 5, I can easily find the values of y for each of these x values. So y1 will be equal to 2 times x1 minus 5, which is 2 times 2 minus 5 minus 1. The first point is 2 minus 1. And y2 will be equal to 2 times x2 minus 5, which is 2 times 1.6 minus 5, which is minus 1.8. So the second point will be 1.6 minus 1.8. So these 2 points are your answers. These are one of the hardest tests in circle equation. So keep in mind that you will need to use quadratic equation rules here. So let's continue with example number 8. Points A and B are endpoints of the diameter of the circle. Find circumference of the circle. So let me just quickly show you. If you have a circle with 2 points, A and B, that are endpoints of diameter, it means that distance between A and B will be your diameter, right? So we have point A with coordinates 2 and 12, and B with coordinates 6 and 8. So let's try to find distance between these 2 points using the formula D, 2 minus 6 squared plus 12 minus 8 squared equals 16 plus 16, which is root of 32, which can be simplified into 4 root of 2. Now, the question is, find the circumference of the circle. C equals 2 pi r, or 2r gives you the diameter, pi d. You can either simply put it here, and you will have 4 root of 2 pi as your answer, or divide the diameter by 2 and get the radius, 2 root of 2, and substitute it here. You'll get 2 times pi times 2 root of 2. The answer will still remain the same, 4 root of 2 pi. So you have to know these formulas also of circumference and area of the circle. Area of the circle is pi r squared. So if they ask you about the area, you will just substitute area, radius here, or use the formula P, diameter squared divided by 4. It depends on your decision. So this one is not that hard. So let's discuss number 8. Oh, sorry, number 9. So find the radius of the circle circumscribed about triangle OBC with vertices at points 0, 0, 1, 0, and 0, 2. So the best way to solve this is to draw this. So let's paste it, have one here. So we have first point centered here, second one is 1, 0, and third one is 0, 2. So 0, 0, 1, 0, and 0, 2. This is A, B, and C. If we connect these with lines, we will get a right triangle. I'll show you. Right triangle with legs 2, 1, and we need to find the radius of the circle circumscribed about this triangle. So as you can see, the diameter of this circle is equal to the hypotenuse of this right triangle. So we have 2 legs. Using Pythagoras theorem, we can find that hypotenuse is equal to square root of 2 squared plus 1 squared, which is square root of 5, which is the diameter. Then radius will be square root of 5 divided by 2, since radius is equal to diameter divided by 2. So the answer is square root of 5 over 2. These ones are easy. You just need to draw it and see that the hypotenuse is really the diameter. So the last example for today, which is very similar to the example number 9, find radius of the circle circumscribed about rectangle ABCD with vertices. Again, the best way is to just draw it. So the first point is minus 1, minus 1. So this point is here. Just symbol here. It is A. Second one is 7 minus 1, B. Third one is 7, 5. And fourth one is minus 1, 5. So now the next thing we need to do is to build up a rectangle. So after building this up, draw a circle which is circumscribed about this rectangle, like this. And now we can see that diameter of this circle is equal to the diagonal of this rectangle. Even if we draw the diagonal, we can see that two right triangles are formed here, and hypotenuse of these triangles is the diameter of this circle also. So the distance from this point A to this point D is -1, from -1 up to 5, 6 units. Distance from -1 up to 7 here is 8 units. So you have 6, 8, then the diagonal will be 10 using the Pythagoras theorem. So diameter is 10, and the radius will be half the diameter, which is 5.